Today we shall discuss about the chapter limit part of calculus. What is limit? When we don't have the exact value, but we have a idea about the value. Suppose 2.99995 or 3.401, that is 3.4 zeros then 1. These two values are not exactly equal to 3, but very nearer to 3. In these cases, we can write that is x tends to 3. That is x not equal to 3, but it is very nearer to 3. So, what is limit of a point? That is, if x tends to a, that means x is not is equal to a, but the value of x belongs to the open interval a minus delta to a plus delta, that is neighborhood function, neighborhood of this point a. In this case, delta is a very small value. X tends to a, that is not including the point a, the value of x lies in the interval a minus delta to a plus delta, excluding the point a. Okay. So, the value of x, it may be less than a or may be greater than a. Okay. If it lies in less than a, then left hand limit, and if it is greater than a, then it will be right hand limit. Okay. Now, limit of a function. The function f is said to tend to a limit L as x tends to a if for each epsilon greater than 0 there exists delta greater than 0 such that mod of x f of x minus L less than epsilon, where epsilon is a very small positive value and x lies in the interval this a minus delta to a plus delta. In this case, we can say limit x tends to a f of x is equal to L. That means, if the point tends to a, then the value of the function tends to L. Okay. Now, if this x tends to a, it is smaller than the value of a, then it will be left hand limit, that is limit x tends to a minus, that is the value of x is smaller than a. Limit x tends to a minus fx, it is known as left hand limit, and in case of right hand limit, the value of x it is greater than a, that is limit x tends to a plus fx. Now, if this left hand limit and right hand limit are equal, then we can say that limiting value of the function exists when x tends to a, that is limit x tends to a f of x exists. Some standard limits which are very useful to solve the problems of limit, that is limit x tends to a x to the power n minus a to the power n by x minus a, that is n into a to the power n minus 1. Limit x tends to 0 sin x by x is equal to 1. Similarly, limit x tends to 0 tan x by x equal to 1. Then limit x tends to 0 cos x, that is equal to 1. All these x are measured in radian unit. Remember it. Limit x tends to 0 e to the power x minus 1 by x, that is equal to 1. Limit x tends to 0 a to the power x minus 1 by x, that is equal to log a to the base e. And then limit x tends to 0 log 1 plus x by x, that is equal to 1. We can prove all these standard limits. How to solve the problems of limit? You see, in this type of problems, limit x tends to 2, 2x square minus 5x plus 6. substitute this limiting value of x here directly. That will be 2 into 2 square minus 5 into 2 plus 6. The value will be 4. Now method of factorization. Limit x tends to 1, x square minus 3x plus 2 by x square minus 4x plus 3. You see here, if you put the limiting value of x, that is 1, directly to the numerator and to the denominator, both the value will be 0. It will be 0 by 0, that is indeterminate form. You can't find the value. So you want to factorize this numerator as well as the denominator. You see, in both numerator and denominator there is a factor x minus 1, for which both the numerator and denominator becomes 0. You are to exclude these two factor for which the numerator and denominator becomes 0. So eliminating this x minus 1 from numerator and denominator, it will be limit x tends to 1, x minus 2 by x minus 3. That is, now put the limiting value directly, that is 1 minus 2 by 1 minus 3, that is minus 1 by minus 2, that is half. Now method of rationalization. Limit x tends to 2, x minus 2 by root over of x minus 1 minus root over of 3 minus x. If we rationalize this denominator, it will be this one, taking common 2, that is 2 into x minus 2 in the denominator. You see, this x minus 2 factor will be eliminated from the numerator and denominator. Eliminating these two and put the limiting value directly in the rest part, it will be root over of 2 minus 1 plus root over of 3 minus 2 by 2, that is 2 by 2, that is 1. Now use of standard limits. Limit x tends to 0, root over of 1 minus cos 2x by x. Root over of 1 minus cos 2x. 1 minus cos 2x means 2 sin square x, that is root over of 2 sin square x by x, that is root 2 into this constant term. The value of this one is not depending on the limit, so we wrote this constant term at the front, then limit x tends to 0 sin x by x. And what we know, limit x tends to 0 sin x by x, that is equal to 1. So root 2 into 1, that is equal to root 2.